everyone. In this module, you will learn about mathematical language and symbols. At the end of the lesson, the students can discuss the language, symbols, and conventions of mathematics, explain the nature of mathematics as a language, perform operations and mathematical expressions correctly, and recognize that mathematics is a useful language. Mathematics as a language has the following characteristics: precise, able to make very fine distinctions; concise, able to say things briefly; and powerful, able to express complex thoughts with relative ease. The language of mathematics can be learned, but requires the efforts needed to learn any foreign language. In this module, you will get extensive practice with mathematical language ideas. You enhance your ability to correctly read, write, speak, and understand mathematics. Let us have an example of being precise. How do you define circle? So kindly try to define circle. So in giving a definition of a term in mathematics, it may be different in giving a definition in the English language, okay, or in the English dictionary. So how do you define circle? So you may check your definition of a circle with this definition from geometry. So a circle is a set of things or a set of points in a plane that are equidistant from a given point called the center. So do you have the same definition with this? This is being precise. Maybe you define circle just a set of points. That is just one description of a circle, but it's not a precise definition of a circle. Or you actually define the circle as with no end. So that's correct. It's a description of a circle, but is it precise? Is that description only a description of a circle? Is it distinct to a circle? So that's being precise. Okay? How about being concise? Kindly try to state the Pythagorean theorem, one of the famous theorem in geometry. So you kindly try it in your own study area. Okay, so this is the concise statement of the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other sides. So that's actually being concise. Okay, it means you have to say things very briefly. It's clear, it's brief and concise, and it's clear. And why math language is powerful. Let's have the same example, the Pythagorean theorem. Isn't it we actually stated it in a sentence, in one sentence? Let's say, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other sides. So if we're going to represent the hypotenuse with a variable c and the other two sides as a and b, okay? So we are now using variables here to represent these quantities or properties, and using variables or symbols or expressions can make, okay, mathematics powerful, because we can actually write a very long sentences or very long sentence into just a very simple equation or expression. Okay, so let's say the Pythagorean theorem. You are very familiar with its equation, isn't it? Using a, b, c. Okay, as to the sides of the triangle. We have the Pythagorean theorem as c squared is equal to a squared plus b squared. Maybe you're so familiar with that equation, but to state it in a sentence sometimes, or maybe some of you do not know how to state it. But the meaning of that is this statement, it in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other sides. So that's one example of being powerful of mathematics. Okay, and we can also use, okay, diagrams, models, figures to represent ideas, and that means math is powerful through this. Mathematics as a language. Every language has its own vocabulary, these are the words, and its rules for combining these words into complete thoughts or the sentences. In this lesson, we will learn the nouns of mathematics used to name mathematical object of interest and the sentences of mathematics which state complete mathematical thoughts. Let us compare the English language and the mathematics language. In terms of symbols, the English language has the English alphabet and punctuations. In mathematics, we use the English alphabet A to Z. We have the numerals. We have also the Greek alphabet, alpha to omega. We have the grouping symbols. We have parentheses. We have brackets. We have braces and some spatial and many spatial symbols. Okay, the noun in English is actually the expression in mathematics. The one that with complete thought are actually both called sentence in English and in math. And we have the action word, we call it verb in English. In mathematics, we call them the operations and other actions like you have to rationalize, you have to simplify, you get the square root, okay? And what's in a sentence? There is a verb in English, okay? But in mathematics, this can be the equality, the inequality, and a membership in a set. And we will learn later the different symbols used to represent equality, inequality, and membership in a set. Okay, in English, the attribute of a fiction, we have a fact or a fiction, but in mathematics, we can say that a sentence can be true or false. So that's the comparison of the English language and the mathematics language. How about a name given to an object of interest? As I said, these are the nouns in English, okay? But in mathematics, they are called expression. So an example in English is Pamplona and Paul are these are nouns, name of person, name of places, events, okay, object. But for mathematics, we have expressions like numbers. We have 1982. We have actually square root of 5. And we can also have some algebraic expression using variables. We have 3x. Then we have also integers. We have negative 8. So these are actually some examples of expressions in mathematics. Then for a sentence, it has a complete thought. An example in English is Tuguegarao City is the capital of Cagayan. How about in math? So in math, it can be equality, it can be inequality, and a membership in a set. So these are examples. 2 plus 3 equals 5. 8 is less than 9. 2 is an element of Z. 5 minus 2 equals 1. So have you noticed here that some of the equations are false or one of the equation is false. So that's actually uh, the expression in mathematics. Ay. For practice test, classify the following entries whether they are an English noun, mathematical expression, English sentence, or mathematical sentence. You may pause this video and try to answer the 10 items. Let us now check your work. The correct answer for number 1 is English noun. Number 2, it is an English sentence. 3 is mathematical expression. 4, an expression. 5 is a sentence. 6 is an expression. 7 is a sentence. 8 is also a sentence. 9 is an expression. And 10 is a sentence. You will learn more on mathematical expression and mathematical equation in the next slide. So what is a mathematical expression? By definition, an expression is the mathematical analog of an English noun. It is the correct arrangement of mathematical symbols used to represent a mathematical object of interest. An expression does not state a complete thought. In particular, it does not make sense to us if an expression is true or false. These expressions are, as I said before, are actually the nouns of mathematics. Okay? They may be the numbers, sets, ordered pairs, matrices, vectors. And these are the examples. Negative 8 is a number, it's an integer. 4x squared minus 3x plus 2 is an algebraic expression. It's actually a quadratic expression. The ordered pair 4, 2, we have the set 3, 5, 7, and we have also a vector, or it can be a matrix 3, negative 2, 0. And these are the objects of interest in mathematics. Just like us, we have different code names or nicknames. Numbers have lots of different names also. Like, for example, 5. 5 can be written as 2 plus 3. 5 can be 9 minus 4. It can be 10 divided by 2 or square root of 25. For 2, it can be 4 times 1 half or 1 half of 4. It can be 8 minus 6. It can be 3 minus 5 plus 4, or it can be the logarithm of 100. How about 3? You kindly try it. Try to give another name for 3. So you may use any of the operations. You can have subtraction. You can have multiplication. You can also have a square root if you want. Okay, so it can be 6 divided by 2. You give your own, so please try. When we solve problems in mathematics, most of the time, when we give our answers, it should be in simplest form. So what do you mean by simpler in mathematics? So in here, it means fewer symbols. So we use fewer symbols. So instead of writing 3 plus 1 plus 5, it can be written as 9. Okay, simpler also mean fewer operations. So instead of adding repeatedly like 3 plus 3 plus 3 plus 3 plus 3, you may just simply write 3 times 5. Okay, simpler also means better suited for current use. So instead of writing 1 foot over 12 inches, okay, that equivalence is actually equal to 1. And simpler means it should follow a preferred style or format. Okay, so you can actually write 1/2 instead of 2/4. So that's being simpler. How about a mathematical sentence? A mathematical sentence is the analog of an English sentence. It is a correct arrangement of mathematical symbols that states a complete thought. It makes sense to ask the truth of a sentence. Is it true? Is it false? Is it sometimes true or sometimes false? Examples are x equals 2, 4 equals 5, 8 is greater than 3, 2x equals 6, and 3x minus 8 equals 10. These are examples of mathematical sentences wherein you can actually determine whether they are true, are they or false, or sometimes true, sometimes false. Let us try this exercise. Determine whether each sentence is true or false, or sometimes true, sometimes false. You may pause this video and try to answer the following items. So let us now check your work. Number 1 is, how about number 2? Number 3, 4, 5, 6, and 7. Okay, so what's your score? Did you get the 7 items correctly? Okay, look at number 1, number 3, and 5. They are actually sometimes true, sometimes false. So why they are actually examples of equations which are sometimes true, sometimes false? What are their common characteristics? Try to solve for the values of x for these equations, and number 1, 3, and 5. Isn't it when you solve for x, there is actually one or two numbers or values of x that will make the equation true? Let's say number 1, 2x equals 8. What value of x that will make the equation true? Solve for x. Is it 4? Is it 4? Yeah, it's 4. How about number 3? X squared equals 25. There are two values of x that will make the equation true. That's 5 and negative 5. About number 5, x minus equals 5. There is one value of x, or there is one real number that will make the equation true, and that is 7. Okay, so if there is actually some values of x or some real numbers that will make the equation true, it means that the equation is sometimes true, sometimes false. Because for number 1, for example, it's true for 4, but for other numbers like 3, it is false. Okay, and then how about number 4 and 7? Why they are called true equations? They are actually called identity equations because they are always true for any real number. So think of any real number that you will substitute to the variable x. The left side is always equal to the right side. And that's actually a true equation or identity equation. It is true for all real numbers. The meaning of is 5 is the square root of 25. In symbols, it can be written like this. So the word is actually tantamount to equal sign. 3 is less than 10. So it can be written as inequality symbol. 3 is less than 10. 7 is a whole number, so it can be written as a membership in a set. So this symbol can be read as is is an element of or is a member of. So 7 is an element of the set of whole numbers. W is actually a representation, okay, a symbol for the set of whole numbers. 8 is an even number, can be written in symbols as 8 is an element of the set of 2n such that n is an element of the set of integers. Okay, let us familiarize ourselves with some mathematical symbols. This symbol is the sigma notation, and it can be read as the sum of. The next one is parentheses. The inverted A is for every or for any, or it can be for all. This one is an element of or is a member of. The other one is a subset of. For the set of real numbers, we use R. For the set of integers, we use Z. For the rational numbers, Q. And for the set of natural numbers or counting numbers, we use N. For W, that's actually for the set of whole numbers. And we have this if then. Okay? Try this one. Translate each of the following sentences into mathematical symbols. 5 is an integer. So how do we represent the set of integers? Isn't it? It's letter Z. Is n, meaning this 5 belongs to the set of Z. So we use that symbol which is like a letter E. So we can write it as 5 is an element of the set of integers. 1/4 is a rational number. The set of rational number is denoted by Q, and is means belongs to, or is a member of, is an element of. So we use the E here. It's like E, no? So 1/4 is an element of the set of rational numbers. How about the square of a number is positive? How do we represent a positive number, or what is the characteristic of a positive number? So a number here is unknown, so we can use a variable. We can use variable x to represent that number. And how to square it? You raise it into 2, isn't it? If you square a number, so it can be written as x squared is greater than 0, because positive is actually described as those numbers greater than 0. How about the values of y ranges from 2 to 5? So if it's actually from 2 to 5, 2 and 5 are actually included in the range. So it can be written as y is actually greater than or equal to 2, but less than or equal to 5. Without the equal sign here, we can actually use the word between. How about the last statement? The square of the difference of A and B is at least 3. What do you mean by at least 3 in symbols? Or how are you going to express at least 3 in symbols? You will use the inequality symbol, greater than or equal to. And when we say difference, that's actually a subtraction of the two numbers, A and B, and you need to square it. So you need to actually have a parenthesis here. So this is the symbol. So this is an example on how to translate an English sentence into a mathematical equations or symbols. How about translating mathematical symbols into English sentences? So you may actually do that by reading symbol by symbol, or there is actually a more formal way. So I will teach you on how to. Let's try number 1. By reading it symbol by symbol, we have for all x element of real numbers, x squared is greater than or equal to 0. That's actually correct. But there's a more valid or a more formal way of stating it. That is, for every real number x, the square of x is greater than or equal to 0. So instead of saying x is an element of R, you can actually just say real number x. Let's try number 2. By reading it symbol by symbol, we have the rex is mn, element of z, that's actually the set of integers. M minus n is less than or equal to m plus n. A more formal way is the rex z is integers m and n such that the difference of m and n is less than or equal to their sum. You may actually try number 3 and 4. So you may pause this video and try to translate number 3 and 4 into English statements. Okay, so check your answers. Let's have number 3. For every real numbers x and y, the square of the sum of x and y is equal to the sum of their squares. And for number 4, for every rational numbers a and b, the product of a and b is equal to 0. Did you get the correct answer? Did you actually translated it right? I hope so. Let us also try to translate English phrases into mathematical expressions. You may use any variable to represent the unknown number. You may use X, you can use actually A, or any other letter in the English alphabet. So I'll give you maybe 1 minute or 2 to answer this. You may pause this video and try to answer. You may now check your work. The sum of 2 and a number can be written as 2 plus x. X plus 2 is accepted because addition is commutative, but the correct order is 2 plus x. How about twice the number? It can be written as 2x. You may not have a symbol for multiplication such as parentheses or that, but you may actually simply write it as 2x. 5 more than a number can be written as x plus 5. The correct order or arrangement is x plus 5. For number 4, 5, and 6, let's actually compare because they may be some similarities in terms of their phrases or words like less than, is less than, and the word less. So how to write 3 less than a number can be written as x minus 3. So for emphasis, if you actually translate the word less than into an expression or symbol, you have to reverse, okay, the arrangement of the two numbers being mentioned, like 3 less than a number. So you need to actually write the number first, which in this case is represented by x. For number 5, the word is less than. So there is actually the word is less than. It can be written as 3 less than x. So you use the inequality symbol less than. And then for number 6, if we have the word less, it's actually just the subtraction or minus sign. And same order, 3 minus x. Let us have more examples on translating English phrases into mathematical symbols. Look at numbers 7 and 8. We have the word the sum of the squares and square of the sum. So what's the difference between these two phrases? How to write the sum of the squares and square of the sum. So for number 7, it is written as x squared plus y squared. Then while for number 8, we have x plus y is squared. The use of parentheses is very important here. It means that you square the sum of x and y, not only the y to be squared. About number 9, the product of x and y. So simply it can be written as xy. And the word difference means you subtract. So there is the subtraction or minus sign. And quotient is for division. So you may use the fraction bar or the symbol for division. And that's all for mathematical language and symbols. If you have any question, any clarification, or something to share, you may actually do that during our MS Teams Meet. See you in our synchronous session. Bye.